with little preparedness. Shoot, I wish we had 2 periods. This would be a blocks class. I say it every year. Okay. All right, here is the Module 1 mid-unit exam. Recall that this is going to be lessons 1 through 17. First topic I want to review with y'all, hopefully it starts off pretty easy, is be able to divide. This one I do remember what lesson it comes from. This comes from lesson 8. Maybe that's where I pulled this example from, and then just started making them up after that. So in example, if I give you something like this, 2 minus 6i divided by 2 plus 5i, when you are asked to divide, you're asked to basically simplify where I can't have an I on the bottom. So what do I have to multiply to get that I off the bottom? The conjugate. What is the conjugate of 2 plus 5i? Very good. Now, again, on y'all's workbook, when I graded this, a lot of y'all did this part, and then on the top, you'll ended up doing the conjugate of the numerator. That is not how you do it. It has to be the exact same binomial. So it needs to be a 2 minus 5i on top as well. Now, when we work this out, remember when we multiply by the conjugate, you just got to do the f part and the L part, or the a squared and the b squared, however you want to write it out. So what's 2 times 2? What's 5i times negative 5i? I squared, right? And that I squared is going to make that negative 25 become a positive. So I become a plus 25. So then what's 4 plus 25? 29. All right. So that you should always end up with a single number on the bottom. Now, on over here, you actually have to FOIL this part out. So we do 2 times 2, 4. 2 times negative 5i. Negative 6i times 2. Negative 6i times negative 5i. 30 I squared. And then that 30i squared will become a negative 30. Do make sure you write the answer in the correct form where the real number comes before the imaginary. So 4 minus 30 is negative 26. And then negative 10i minus 12i is, okay. You must write it out in the correct complex form, which is a plus bi. So you split this up into 2 separate fractions. So this becomes negative 26 over 29 minus 22 over 29i. Simplify if you can. 29 happens to be a prime number, so that's as far as you can go. So hopefully now you'll know how to put a fraction in by hitting the fraction option button on the little keyboard. Go ahead. Oh, okay. Yeah, so the boxed one. Technically, you are right here, but it's going to want it in that rectangular form, which is a plus bi. I'm going to say yes, but the test was taking some of the unsimplified answers, but I don't know if you want to risk it on a test. I would write it like this rather than this. Any other questions there? All right, the second topic I would like to discuss, and I don't remember where these come from, but you need to be able to tell me what happens if you take the conjugate geometrically. So geometrically, what is the cause of a conjugate? Very good. reflects over the x-axis, or also known as the real axis. All right. So for instance, we had to do an example here. Let's say z is equal to 2 minus 6i. To graph this, I go right 2, down 6. Here's my point. What is the conjugate of this guy? 2 plus 6i. So I would go right 2, up 3, 4. And there's my graph. So there's z, there's z's conjugate. So the big thing you need to know is that the conjugate, for something to be a conjugate, it must reflect over the x-axis exactly. Right? So if I'm 6 spaces down, I better be 6 spaces up. Don't get one that's like 5 or something. Questions on the second topic? That's it. That's just, you got to know that. It's not really like a answer type thing. It's just you need to know that geometrically the conjugate reflects over the x-axis. So if I was to plot z, z conjugate will be right there. So if I goes like, all right, so z is 2 plus 6i or 2 minus 6i, its conjugate would be graphed at 2 plus 6i. That's what you need to grasp from this. So if I put a random dot here, I put a random dot here and I call it w, its conjugate would have to be whatever that is. Let's say it's k or something. Then you could say k is w's conjugate, or k is, or w is k's conjugate, or whatever they reflect. Does that make sense? All right. Third topic. Still confused? What are you confused on? Oh, I thought you said you were still confused. All right. So if, let's say z is equal to 2 minus 6i, I'll end up using this example like pretty much throughout this whole review because I'm not very creative. Yeah, like it's going to be pretty much the same. Like I'm not a creative guy here. And then let's say w happens to be 2 minus 5i, or sorry, 2 plus 5i. And these are the things I need you to be able to do. I need you to be able to graph z, z with a line over it, negative z with a line over it, z minus 2i, w plus 2, z minus w, and like negative w plus z with a line over it. All right, so you gotta be able to find it, and then you gotta be able to graph it. So for instance, z is simply just 2 minus 6i. That was given to you. So on my graph here, I would go 1, 2, 1, 2, 3, 4, 5, 6. Here is z. Okay. What does this line above this z mean? Conjugate. So what is the conjugate of z? So I expect you to be able to graph that. So that's 1, 2, 3, 4, 5, 6. If I put a negative in front of it, what is that going to happen here? Bless you. Yeah, good. It's going to change the signs of the conjugate. So that's going to be negative 2 minus 6i. I'll change both of them. All right, so that means I go 1, 2, and then I go down 6. We also learned that this was also called the opposite conjugate, which is the what reflects across the imaginary axis, right? But you just got to be able to graph it. This one, literally, you would just take 2 minus 6i minus 2i. And to do this, you literally just combine like terms. What is minus 6i minus 2i? So that becomes 2 minus 8i. So I'd come over here, 2, drop 2. Here I am right here. So that would be z minus 2i. W plus 2, I'm literally going to go 2 plus 5i plus 2. So what would I do to combine this one? 4 plus 5i. So then now I go 5 would be right here. So about right there would be what w plus 2 is. Z minus W is 2 minus 6I minus parentheses 2 plus 5I. Make sure you put that that second letter in parentheses so that when you're doing the math, this is 2 minus 2. What's 2 minus 2? 0. And then this is negative 6 minus a positive 5I. What's that give me? Negative 11I. So that's basically just going to be 0 and then negative 11. So 1, 2, 9, 10, 11. So about right there would be Z minus W. All right. This one you can do in multiple ways. You can do W plus Z, then take its conjugate, or you can take the conjugate of both of them, then add it. I find it to be easier to work like inside out. So I'm going to do W plus Z first. So I'll do Z minus, oh, my bad. So that'd be, so W plus Z would be 2 minus 6I plus 2 plus 5I. When I combine like terms, what do I get? 4 minus I, good, because negative 6 plus 5 would give you that. So I get 4 minus I. Then I would apply the conjugate. So then what's the conjugate of this? 4 plus I. Then I would apply the negative. So if I apply the negative to this final part of the answer, what do I get? There you go. And that would be your final answer to graph. So you go 1, 2. There you go. So there's your negative W plus Z conjugate. I believe on the test, they give those answers. Like they'll say that like it's K. And so you'll just say it's K. Does that make sense on how to find it and how to graph it? We're good there? All righty. The fourth thing I want you to be able to do is I want you, just like on the quiz, be able to find the midpoints. All right. And distance. Most of y'all did pretty good on the distance part, but there was a lot that got midpoint wrong. All right. Know that midpoint is x1 plus x2. I think some of y'all were subtracting or something. I don't know how y'all got some of the answers. And then this is y1 plus y2 divided by 2. So if I say, let's see, let's say A equals 2 minus 6I. And if you can guess, B will equal 2 plus 5I. It just works out for me. So if I want to find the midpoint, I'm going to add the real terms. I'm going to add the x's. So I'm going to go 2 plus 2 divided by 2. And then it's going to be negative 6 plus 5I. And what's that give you? Oh, sorry. I guess I need to write it out first. There we go. So 2 plus 2 is divided by 2, 2. Negative 6 plus 5 is negative 6 plus 5. Negative 1. Good. And then the divide by 2. All right. I don't remember if it accepted this as an answer. I think I went back and gave you credit if you did write it like this, but the computer program would like you to write it as 2 minus 1/2 I in complex form. But I will say if you end up writing it like that, I will probably still go back and give you full credit for it. I did get partial credit again because I think the answer on the test was negative 5, comma 6, but some people wrote 5, comma 6. So someone just forgot the negative. I don't know. Maybe you just forgot to type it because I didn't see no work to go with it. So I just gave you some partial credit for just missing the negative. Right? All right. So that's midpoint. To find distance, remember, it is the square root of the difference of your x's squared plus the difference of your y's squared. So in this case, that will just be 2 minus 2 squared plus negative 6 minus 5 squared. Don't stress about the order, right? The order is not going to matter. It's just about finding the difference of them. So what is 2 minus 2? 0 squared. What's negative 6 minus 5? Squared. 0 squared is 0. Negative 11 squared is It is 121. 0 plus 121. And then the square root of 121. 11. They come up with a random questions that actually gave us nice clean numbers. Who'd have thought? Questions on that? Again, this is kind of a review of what you're supposed to do on question 1 of the review as well, or the quiz yesterday. We all good? All right. Again, if this would have been a square root, the computer program did accept a unsimplified square root. So if you would have took the square root of 180 and left it like that, you did get full credit there. It does not accept decimals, just an FYI. Oh, were you still typing? I'm so sorry. It did. So I'm not going to stress about you simplifying it. If the computer program's going to accept it, I accept it too. Who am I to argue with the computer? It did. It accepted both. It said it wanted the simplified version, but it still accepted the unsimplified. So why stress yourself out if it's going to accept the unsimplified answer? All right, the fifth thing you need to be able to do, be able to find the modulus. And the argument. What does modulus mean? The distance, right? So that's the distance. And how do we find distance? Right? But this time it would just be just a squared plus b squared. So if I gave you an example of, let's say the square root of 3 plus the square root of 3i, I changed it up a little bit because I do realize y'all struggle with square roots. When I work this out, this will be the square root of 3 squared plus the square root of 3 squared. What's going to happen to the square root and the square? Cancels on the inside. So therefore I get 3 plus 3. What is 3 plus 3? 6. But notice I still have a square root around it. The square only canceled the square root on the inside, but the square root, the big square root, is still there. Okay. Good there? Okay. The next thing you got to be able to do is tell me, what does the argument mean? Yeah, you can't go any further. Yeah, don't type a decimal. All right. Leave it at square root 6. It can't be simplified, but even if it could, you can put the unsimplified version, but do not type a decimal. Yes. It was R. Or also, if I would have said this is equal to Z, it can also be written as this as well. All of those mean the same thing. Go ahead. So if you're looking for the distance between 2 points, which is what part 4 was asking for, the distance between 2 points, that's when you got to find the difference of the x's and the y's. Like I said, in physics, Mr. Whiting said he taught it as y'all move the vectors to the origin so that you could just do the square root of a squared plus b squared, which is fine. To me, that seems like a lot of work to take it and move it when we can just find the distance this way. If you're only given 1 point and you have to find the modulus, then it goes down to just the a squared plus b squared, because it's basically finding the distance from the origin. I think most of the time it actually probably says what's the modulus of an argument from the origin. Any other good questions like that? Okay. So what does argument mean? Theta. Very good. This was on y'all's quiz as well. And how do I find theta? It is. I could just write. Oh, to find the unit vector. Yes. Yes. So this would be tan inverse. If I can write a 1. B in this case would be square root of 3 divided by the square root of 3. Type that in the calculator. What do you get? Something. Only have 20 in here, and there's only like 8 of y'all. 45 degrees. Very good. All right. As I said yesterday, I guess maybe I haven't said it yet. On question 5, it specifically asked for the radian, but it accepted the degree. So if you're more comfortable with degree, just write the degree because apparently it accepts it. But it didn't accept it if you forgot the degree sign. So do make sure that little symbol in the little keyboard calculator they give you that you put that degree sign there. The second thing you need to pay attention to, what quadrant am I in? The first, do I need to do anything to this? Then leave it like that. Pay attention though on the test, what quadrant you fall to see if there's an extra step for you. So you graph it. So like for instance, the square root of 3 plus the square root of 3, you don't got to pay attention so much to the number as pay attention to the sign. A and B are both positive, so you're going to be in quadrant 1. So you don't have to do anything to theta. But let's say maybe both of them are negative, and you had negative square root of 3 minus square root of 3. Then you're going to fall in quadrant 3, so I need to add 180 to it. To that 45 that gives you the calculator. Perhaps, maybe. Yes, but we also created this as well. Oh, yeah. You can always do it on the back end. Yes, ma'am. It just depends on what the question asks. Theta can be represented as degree or radians. It can be both answers. So like on the test, the answer was pi force. That's what it wanted. Oh, sorry. Okay. So the theta that you calculate from your calculator, it depends on what quadrant you fall. If you're in quadrant 1, it's going to give you this counterclockwise motion, which is perfect. That's what we want. But over here, it'll give you this clockwise motion. That's why it gives it to you as a negative. So you have to add 180 to get the actual counterclockwise answer. Here, it gives you the counterclockwise motion, but it only goes from here to here. So I have to add 180 to get the full answer. And then over here, same concept, it will give you this clockwise motion. That's why it gives you a negative in quadrant 4 as well. But if I add 360, I can get the counterclockwise. It's always the counterclockwise answer that we want. Yeah, so yeah, they're both still theta. And then it rotates over and over again. So really ensure you're getting the same answer because you can add 360 or negative 360 as many times as you want. But we want specifically an answer that's between 0 and 360, and we want the counterclockwise motion of it. All right. Yes, sir. Oh, and that only it's only going to happen if you land on 90 or 270. Oh, I got. Well, that's the only time it'll ever happen. So, for instance, hypothetically, let's say you have like 0 plus 2i or something like that, and you're asked to find the argument. So this would be tan inverse of 2 divided by 0. Well, you can't do that because you can't have 0 on the bottom. You would then calculate the modulus. So that's going to be the square root of 0 squared plus 2 squared, which is just going to be 2. And then from there, you would take your coordinate 0, 2, divide them both by 2. So you get 0, 1. And then from that, you then come over here to 0, 1, and we can see that that corresponds to 90 degrees. And then that would be your answer. Yeah, I don't remember what class it was, but after thinking about it a little bit, it's only going to happen at those 2 degrees because that's the only time. Again, you don't know this yet. You'll learn this here soon. But tangents equal to sine over cosine, which is the same thing as y over x. So anytime x is 0 on a coordinate plane, which only happens twice, that's when you get that undefined situation. Any other good questions like that? Are we? Yeah, we're literally halfway through. All right, the next thing you need to be able to do is convert from rectangular form to polar form. So for instance, if I say z is equal to 2 minus 2 square roots of 3i. That's my rectangular form, and I want to go into polar. There's two things you got to do first. One, you need to calculate your R. How do I calculate R? Got to find the modulus. That's going to be the square root of 2 squared. How or ow? Oh, okay, good. I thought you said how. It's like it's just that goes the humorous. But it's funny because now I know. See, I learned with y'all because she studies at home, so I'm like her first student. Huh? It hits like a nerve or something, doesn't it? That shoots up a yeah, then it shoots up to your whatever that part of the brain is that tells you pain. I might have zoned out. All right, so 2 squared is 4. And then negative. So, okay, so this is the next thing. I think this was on your quiz. That's why I brought it back. When you square something that has a number and a square root, you have to apply it to both. So the first thing, figure out what is negative 2 squared? 4. So that will give you plus 4 times what's the square root of 3 squared? 3, because it'll just cancel. So that ends up actually being 4 times 3 right there. On the quiz? Yeah, I think a lot of people who got it wrong is that was where the mistake happened. So you just didn't know how to apply it. Or maybe it was a homework assignment. I don't remember. I think this was a quiz. So then 4 times it's on the test for sure. I thought it was on the quiz. I don't know. 4 was it? It was. Okay. So then 4 times 3 is 12, and then 4 plus 12 is, and then the square root of 16 is 4, which gives you just 4. No square root left. Then I gotta go find theta, which we already wrote down is just the tan inverse of b divided by a. So the b, the signs do matter when you are calculating this. So make sure you put negative 2 squared roots of 3 divided by 2. Don't put the I in there because you won't get an answer, but do carry the signs. I don't know this by heart, so you're going to have to tell me what this is. 2? Was it 45 even? Nice. Yeah, you just type it in the calculator just like that. Oh, you guessed. Okay. So y'all got negative 60. That sounds a little bit better. What mode is your calculator in? Make sure your calculator is in degree when you do this part. Actually, really and truly, to be honest with you, we do most of our stuff in degree. Just make sure your calculator is just in degree when you grab your calculator. I done forgot where. So y'all got negative 60. What quadrant does 2 minus 2 squared root of 3 fall into? Quadrant 4, because 2 is a positive. Because again, don't pay attention too much to this, the numbers. Pay attention to that fact that it's a positive and negative. So since I fall in quadrant 4, what do I got to do to that degree? Add 360 to it. Yeah, some of y'all did, and I could tell. So therefore, I get 300 degrees. Don't forget that degree sign. Now, that's just your prep work. The actual work, actually, no. That's right. Sorry. That's most of your work. Now you got to finish the question. So polar form is R times cosine of theta plus I sine of theta. You're just plugging it in, just like on the quiz. You're not actually working it out. So my R was calculated as 4, and my theta was calculated at 300 degrees. So cosine 300 degrees plus I sine of 300 degrees. Once again, though, if the answer is asking it in radian form, instead of 300 degrees, what would my radiant be? 5 pi over 3, all right? Both of those are the same answer. Be able to go back and forth with it. Any questions on the 6th topic? Yes, ma'am. Thank you. All right. 7th thing. Just like on the quiz as well, be able to describe the dilation. And I think this was question 3. This was one of y'all's question 1 and question 3 was y'all's highest scoring question. So I like the statistics it gives me. So y'all did pretty good on this question. I think it was like 80% got question 1 and 3 right, 60% on question 2, 40% on question 4, and then it was like 17% on question 5. So that's why I added that 20-point curve there. Yeah. It will. I think if I explain like how to do it, I think y'all got the math down. But the question was weird. Word it weird. Sorry. Thank you. All right. So again, be able to describe the dilation and rotation from a graph. This graph's going to look slightly different. It's still going to be your basic square. So there's your A, there's your B, here's your C, and here's your D. So now there's your A, B, C, D. But the correlation to this is going to be something, not this exact thing. We're going to pretend this is a perfect square. I think this dot needs to go there. Let's pretend that's a perfectly drawn square and not a skewed parallelogram. All right. Okay. So, anyways, but these kind of pages, these lines here, like this would be coordinate 3, -3. This would be -3, -3, and this would be 0, -6, and of course, and of course, this would be 0, 0. Right? And then these are still those same 1, 0, 1, 1, 0, 1. All right. First thing you need to do is I need to tell you, I guess, which one is which. So this would be your B prime, this would be your C prime, and this is your D prime. So when you're looking at this, kind of determine, like if I was to turn it here, that would be 90 degrees. If I turned it into this box, which is what y'all saw in y'all's quiz, that was 180 degrees. But then if it goes halfway, it doesn't go quite 90 degrees, I need to take that and add it to 45. So what is 180 plus 45? 180 plus 45, 225. Good. So this rotation here is actually going to be a 225 degrees counterclockwise. All right. Let's pretend this is my first square. So we know if we go way over here, that was a 90-degree turn. And then that put right here. And then if I go here, that was another 90. So that was 180. That's what you saw in y'all's quiz. But here, I didn't quite go all the way. I went about a half turn. So that would be an additional 45 degrees. So if I went 90, 180, well, it's because it landed right on the y-axis. That's how you know it's a half turn. Had it been skewed not on the y-axis right here, on the C prime there, yeah, then I could say, oh, I have to do some math to figure this out. But this part, if it lands on the y-axis, which it will, it'll land on a axis, sorry, one of these axes. If it lands on it, then it's going to be a 45 half-degree turn. You're not going to see it. It had to be in between that, yes, but we'd have to do some more math to calculate it. Oh, and then so therefore D would actually land right there, and that'd be only 180 degrees, which is what you saw in your quiz. So like if B lands here, D's gonna land there, and that was just 180 degrees. That's really, yeah, that's how actually I calculated. I go, alrighty, that's about 100. or 225 degrees, right? Because it's got to be somewhere in this ballpark, right? When you look at the turn, you're like, it's got to be one of these numbers. And this looks like it's about halfway, so I'm going to go with there. So that's kind of what you do, kind of eyeball it. Absolutely. Absolutely. And what, I don't know if y'all caught that, but Luke said he just pays attention to the line segment AB and just sees how did AB from here change to here. And then that right there is 225 degrees, which is a great way to look at it. Yes. Okay, so in this case, the dilation's a little bit different. So to figure out the dilation, you have to figure out what the length of these guys are. That's going to tell you your dilation. But the issue is you kind of have to figure that out. It doesn't really tell you. So what you can do here is do a little math. And let's go to about right here to the center of the square. Let's build a triangle to calculate what that dilation is, right? So we know that this would be 3. We know this would be 3. So then we can do what? You go ahead. What do you mean this way? Oh, maybe. Maybe I'm just trying to do something more complicated that's going to be on the test. Or the alternative, it could be on the test. Okay, so to find out that hypotenuse, we go back to our original thing, which again goes from a squared plus b squared. That's how we got the distance formula, was by calculating what that gosh, the hypotenuse is, which is basically what your distance from the origin is. So when we do that, that's just going to be 3 squared plus 3 squared. What's 3 squared? 9 plus 9 is 18. Very good. Again, just like what I've learned, it doesn't seem to care to simplify the answer. So your dilation would be the square root of 18. And I would just leave it like that. Technically, that would be more accurate. But it'd be no, it'd be 3 squared to 2. Yeah, it's the 2 would be the leftover though. So this, it seems to accept, but if you did want to go further, it would be 3 squared to 2 as the final answer, but it does seem to have accepted that value as well. Okay. So that's how you calculate the dilation if it shows up on your test. Okay. All right, let's look at the 8th part. 12. So we're going to find the rotation and dilation of something that's given to you as this. If I say find the dilation and rotation of L of Z, and I say that it's 2 minus 6i times Z, does this Z matter? No, I'm just wondering, what is this going to have an effect on any Z that's given? So I do not need to know what Z is. I just need to work with this one. So when I work on the rotation, how do I find the rotation? Rotation. How do I find rotation? The I. What do you mean? How do I find rotation, guys? Tan. Good. It's the tan inverse of B divided by A. Right? That's the degree of rotation comes from the tangent. So it's going to be tan inverse of -6 divided by 2. Tan inverse of -3. If I had to give a ballpark range, I bet it's going to tell you. I was going to come up with this. All right. Sorry. What was the answer? What quadrant does that fall in? Good. That's a positive comma, a negative. So that would be the fourth one. What do I need to do with that guy? Plus 360. And when I do that, what do I get? 18 or 80? So we'll go 4. Right? That would be your answer. Don't forget your degree symbol. And then the dilation. Remember, would just be the square root of a squared plus b squared, which in this case is 2 squared plus -6 squared. What's 2 squared? What's -6 squared? Ooh, always going to be positive. And then 4 plus 36, 40. Again, it does seem to accept this. And if it doesn't, I'll go back and give you the credit. But if you did want to impress me, this is 2 square roots of 10. Well, 40 breaks down in 4 and 10. 4 is a perfect square, so the square root of 4 is 2. 10 can't be broken down but 2 and 5, so it has to be 10 as the leftover. 20 and 2, then 2 and 10, same concept. One more time. Oh, sorry. Go ahead. I can. Number 9 in 3 minutes. No, we have 4 more. I hope so. Why? That doesn't seem like a realistic reason to give y'all another day to review with the people that are not here with so that y'all have an extra day ahead of them. That doesn't seem like a good reason. All right, so just like on the test as well, you need to be able to find the Z and W. But instead of it giving you the modulus as an argument, it gives it to you in a different form. So it will give it to you in a form similar to this, where it'll say Z is equal to 3 cosine of 60 degrees plus I sine of 60 degrees. And then it'll say W is equal to 2 cosine of 90 degrees plus I sine of 90 degrees. Do know I'm not giving you the exact numbers, guys. Just be wary. Make sure you can do the process. Go ahead. How long do I got left until the bell rings? We're going to move the test to Thursday. I can go over the last, well, I'm not going to be here after school anyways. I'm being pulled to a meeting. 3 weeks. There was. All right, sorry. Let's go talk about this. So again, it doesn't say, hey, the modulus this or the argument's this, but you can look at this and tell me what is the modulus of Z? 3. It literally gives the answer right there. What is the theta of Z? 60. And then what is the modulus of W? 2. And what is the theta of W? So even though it doesn't flat out come out and say, hey, this is the modulus, this is the argument, now do your math, it just gives it to you in a different form, but you can still pull what you need and find the answer that you need. You need the modulus of Z and W, and Z times W is just going to be the same thing as 3 times, oh, let me break this down, is the same thing as the modulus of Z times the modulus of W. So I can say this is 3 times 2, which is 6. That is your R. And then to find the theta, we just got to find the argument of Z times W, which we learned was the argument of Z plus the argument of W. So that would just be 60 plus 90, which is, no, 150, ain't it? 150 degrees. So when you write this answer out, Z times W would be 6 times cosine of 150 degrees plus I sine of 150 degrees. Huh? I'll finish this up starting tomorrow. You can tell your compadres that the test will be moved to Thursday. I'll only finish what needs to be finished. So they still need to go look at the review, or you can get with them as well.